So I'm going to talk a bit about what I've been up to with the Raspberry Pi PICO. Quite a bit of which I've been doing with a Raspberry Pi as the thing that programs it, although as we can see, you don't have to do that. And I thought I'd start by explaining why I got so excited about the PICO when it first came out. And part of it is just, it's such amazing value. The chip is about £4, and for that you get a dual core machine with a lot of extra stuff. The extra stuff includes all the things you'd expect. So there's plenty of GPIO pins. You've got UARTs to do serial communications, 2 I2C channels and 2 SPI channels. But the thing that got me most excited was the programmable I/O. This is something that is specific to the PICO, although there have been things a bit like it on BeagleBones and other hardware. But essentially, as well as the main ARM Cortex chip, you've got a lot of little tiny processors which you can independently control to do interesting I/O things. And there's a whole range of stuff that I'm keen to experiment with. Not sure how many people have come across Dallas One Wire, but it's a protocol that minimizes the number of connections you use. People have used it quite a lot in building control, because essentially you need a ground wire and a wire that is both a signal wire and a power wire, and that's all you need in terms of protocol. Trouble is that not that many processors have APIs that support it. Arduino does, I think, and there are drivers for the Pi, but it ought to be really easy to implement one from scratch on the PICO. And there's a lot of other stuff as well, where there's an unusual protocol that you'd like to have, and normally you have to resort to bit banging, but with PIO, you ought to be able to do that in a way that doesn't place any load on the CPU. So there's lots I want to experiment with there once I've got time to do that. Another big plus, of course, was that the PICO is part of a huge community. And on the day that the PICO was announced, Adafruit and Pimaroni and Arduino all stepped up and said, we're going to produce products based on the chip, which was amazing. And we're beginning to see a lot of engagement for a lot of different users. It came out with a lot of documentation. I'll talk a bit more about that in a minute. And also, there's lots of stuff to explore, but I suppose the one warning I ought to give is working with the PICO at the moment is a bit like working with the Pi was in about April in the year that it was announced. So there's a huge amount of enthusiasm for it, and there's a surprising amount of stuff that works, but it's much harder work than you'd expect to spend now on something like the Pi, because that community is so mature. This is new stuff, and my own feeling is it's going to be a few weeks before it's really suitable for beginners. There's lots at the moment that you need to search quite hard to find out. In particular, the documentation, it's got some very, very strong things to be said for it, and it's got some problems. Huge amount of documentation there when it came out, but it's not quite complete. I got a plaintive message on Twitter today from Mike Cook, who is trying really hard to find out how to drive the UART for serial communications. And in the end, the only way that I could find out how to do it, I'd always assumed it was easy. The only way to find out how to do it was to look at the source for that port of the MicroPython. And it turns out to be easy. And now I've posted a gist and put some code up on the site. But all the documentation says is, here are the standard pins you should use. And there was no code, no MicroPython code there at all. And great though the documentation is, it tends to be a bit weighted towards people who are developing in C or C++ rather than people developing in MicroPython. It's also one of the problems with reference documentation is that the author or authors tend to try and avoid repetition. And as a result, if you want to find something out, you often have to refer to more than one document. And I'll list all the ones that I've found in the resources at the end. But it can be a bit of a jigsaw puzzle finding out how to do even fairly simple things. There is a jolly good getting started guide. You can buy the physical book for 10 quid or download the PDF for free. But one of the problems for me with the Getting Started guide is it's aimed at complete beginners. So it assumes you've never programmed in Python before and you've never solded anything. And if you've never programmed anything before and you've never solded anything, that's great. But if you have, the Getting Started guide is a bit slow paced. Things I think we need, and we're beginning to see now, are lots more how-tos, lots more tutorials, and in particular, a couple of people have pointed out that the Getting Started guide assumes that you're using a Pi to program your Pico, but most of the world uses Windows. And those that don't use Mac OS or might use Linux on a mainframe, and the way that you need to connect to the Pi and drive it is slightly different depending on which of those you're using. So hopefully we'll see more and more tutorials that cover all those bases. There's not a lot of information about what to do when things go wrong. So I think we need more facts, and we certainly need more troubleshooting guides. Oops. I'll quickly run through the stuff that I've used for the development I've done so far. And the first thing to watch out for is that there are actually 3 different versions of MicroPython out there, and you need to think fairly carefully about which you're going to use. There's the version that the Raspberry Pi Foundation distributes, which works very well. Slightly scary, because when you download it, the last time I did, it warned that you were downloading an unstable version of the software, but it seems to work pretty well. If you're using any of the Pi hardware, then you'll need to download their fork of MicroPython. And Adafruit have produced a fork of MicroPython called CircuitPython, which has a lot of good features, but it's a 3rd different version. And if you're going to use their hardware with the Pico, CircuitPython is the one that you'll need to use. Editors. The Getting Started guide recommends that you use an editor called Tony, currently on version 2.3.5. If you install that from the repositories, you'll get an earlier version, and it's quite likely it won't work with the Pico. So you need to make sure that you upgrade that to the latest version if you're going to use it easily with the Pico. I guess one of my favorite editors with small boxes is the Moo editor, developed by Nicholas Tollerby and friends. Um, on the whole, it works reasonably well with with a lot of the MicroPython boards. There's a new version out real soon now, which will specifically work with the Pico. One big issue for me, though, was that that new version will not work on the Raspberry Pi. So if you're using that to program things with, probably you need to forget about me for now, which is sad. Most of what I've done has been using either PyCharm, which is my normal Python editor, or Visual Studio Code. I have to admit, I'm getting more and more attracted to VS Code. It's got tremendous range of facilities, very good for developing with the Raspberry Pi because you can develop remotely, but neither it nor PyCharm out of the box will transfer the code that you've written to a Pico. There are fairly simple workarounds for that. In particular, there are a couple of programs called Ampy and PyBoard, which you can use to easily transfer code from the host to the Pico and back again. I got very excited about Ampy because Les Pounder suggested it to me when I was having trouble with another alternative, which didn't work very well. However, I found there is two problems with Ampy. The first is that right now, if you've got a binary file on a Pico, it will not transfer it up to the host, whereas PyBoard will. The other problem with Ampy is it used to be maintained by Adafruit, and it's now been taken over by a smaller group. And that leaves me a bit anxious because I'm just not sure how much effort will go into it and how much resource there is to test it. However, I do use it fairly regularly, and for everything other than the binary file transfer, Ampy does a good job of sharing information between a host and a Pico. Les Pounder also put me on something called TIO, which is a superior terminal app. Certainly runs well on Linux. I'm not sure how well it runs on other operating systems. And its big advantage over things like Screen is that if you get disconnected, it will wait until it can and then reconnect you. And if you're unplugging and replugging a Pico, that's quite a godsend. So TIO is very much recommended. In terms of hardware, you'll obviously need a Pico, and these days, several vendors, not just Primarily, a few others, are offering the Pico with pre-soldered headers. And if you're not keen on soldering, that's a very useful option. Lots of other hardware that use the same chip from the Raspberry Pi are on their way. I had a chance to play with Primarony's Tiny, which is a super thing and should be available fairly soon. Adafruit have got a whole raft of chip-based products coming along, and Arduino are working on a board based on the chip, which comes with Wi-Fi and Bluetooth, which should be very interesting. You can do lots of stuff just with the Pico on its own, but I fairly quickly got started with the Primarony Explorer base, partly because it comes with a very useful little screen, which I absolutely love. I had a lot of fun playing with that. I'll talk a bit more about that later. Very easy to connect to the Explorer base. One of the problems with the Pico is that although all of the pins are labeled, they're labeled at the bottom of the board, which means that if you've got the board plugged into a breadboard, you can't read labels. By contrast, the Explorer base has all the pins and a little breadboard on top, and it's got its own breadboard, and it's got slots for some of the time-only breakout boards, so that you can drive all kinds of interesting I2C and I2C space stuff just by plugging them in without soldering into those two slots there and there. I've managed to get quite a few experiments done. What I wanted to do when I first got hold of one of these was just make sure that all of the things that I normally use to connect to other chips worked, and I knew how to drive them. So I've used the MCP 23008. Richard, I think, has used those in the past. A lot of people have. They basically allow you to add a lot of extra GPIO ports and control them from the PICO over I2C. One of the nice things about the PICO is that it comes with an analog interface, unlike the Raspberry Pi. It's got 3 quite usable ADC converters that will allow you to read an analog voltage and pull the value into your program. But sometimes you need more. And one of my favorite chips for doing that is the MCP 3008, which is an 8-channel analog to digital converter that you can drive over SPI. And that works extremely well, extremely easily. I've posted the code I used to do that. I also played around with a digital to analog converter, just really to see if it could easily be done. I used the AD7303 and that works for me. One of the other things that makes life easy with the PICO is that, like pretty well all MicroPython boards, you can connect it to a host using a USB cable and then send Python commands to it from the host. And when you print stuff from your program in the PICO, whatever you print from Python will go back to the host. So it's fairly easy to set up bidirectional communication without having to do all that grotty serial I/O stuff. And one of the things I did very early on was get the PICO to read a couple of knobs which behave like the knobs on an Etch-a-Sketch, and then send the value on those 2 potentiometers off to a host, which then used GUI 0 to do sort of Etch-a-Sketch emulation on the host. That's quite fun, but it'd be even more fun to do it on the screen that's on the Explorer. And the next day or two, I'm going to try and build a really small standalone PICO Etch-a-Sketch, which will draw on the Explorer. So played around a bit with a simple oscilloscope and a function generator. There's a lot more I want to do with that. But again, the code that I did with that is up on the GitHub repository, which I mentioned at the end. I said earlier that a couple of people had asked about how you drive a USART serial port if you want to. That's one of the gaps in the documentation as far as MicroPython is concerned, but it turns out to be very simple. And again, I've posted some snippets about how to do that on GitHub. Project that's taken up quite a lot of my time the last 2 or 3 days is something called microplot, which is a very, very simple plotting package which will run on the PICO and eventually on other boards as well. And the goal there is to be able to plot some of the analog data that you might be reading on the OLED display that you get with the primarily Explorer base, or with other displays. There are lots of other displays that the Pico will support. And I've ended up with code that's really pretty simple to write. Here I'm creating a set of sine wave values by using the standard Python and MicroPython math code to convert a set of degrees going from 0 to 360 in steps of 4, calculating the sine values, and then I just say, okay, I want to do a line plot of that, and I'm going to use the Explorer plotter because I'm running it on Explorer. Plot the data, please, and write the output once you've displayed it to a bitmap file. And sure enough, there you can see sine wave being displayed on the Explorer. And down below, there's the bitmap file, which when you look at it on the host computer, exactly matches the display. So huge range of stuff. I'm obviously very grateful to Raspberry Pi people for producing a very nice product, but I'm also extremely grateful to Damien George, who's the guy who created MicroPython. In that picture, you can see on the right his original Pi board, going back to 2014. The Pi board is traveling a bit. It's quite likely to be up in space before too long, because the ESA have adopted MicroPython as a suitable language for satellite use. I mentioned resources. I will put the PDF of this talk up on the Raspberry Pi website tomorrow, which will turn all of these into clickable links. But the first four are the main resources I've used: the Python SDK from Raspberry Pi. Some of the information about what you can do is in the datasheet for the chip. Some of it is in the datasheet for the Pico, and some of it is in the Get Started book. So, and some of it is in the C++ documentation, so long as you can work out how to translate the C++ stuff into MicroPython, which isn't always obvious. So there's lots of documentation that you might need to look at to find out how to do stuff. Fortunately, Tom's Hardware, partly because Les Pounder is now working with them, has produced a whole series of really good articles about the Pico and what it can do and how you can do it. I've posted quite a bit on my blog. There's a group on Facebook which covers pretty well all the MicroPython ports, which I've started using. When you can click on that link, you'll be able to join that if you want to. I've put a lot of generic Pico code on GitHub, and as a separate project, because it isn't Pico specific, I've open sourced the microplot code. So lots there, but people are still coming up with a lot of questions. And one of the things that I'm wondering is whether I ought to try and do a rather more extensive cookbook. And I'd love to get some feedback. If people think I should or shouldn't, and you're on Twitter, tweet to Airblog and just let me know whether you think it's a good idea or not. And if it is, I'll do it. Okay, that's it, Richard. Any questions?
Thanks very much. I did have a question. So the Pico, I guess it starts immediately, does it? It's not like the Pi that takes like a minute to get started. There's no operating system to load or anything like that, is there? So just as soon as you power on, it's up and running.
It's, I guess it's probably a millisecond or so for the thing to fire up, maybe less than that. So yeah, it's instantaneous. It's like an Arduino in that sense.
Right, but I guess so when it starts up, you immediately download some code. Is that how it works, or do you have to? The code's not resident on it, is it?
Yes, it is. It's got a proper file system in Flash, and so when you power it on, if there is a program called main, it will run it.
Okay. Yeah, because one thing I was trying to do a few years ago was just replace like a light switch or a lamp with a Pi, but you don't want to wait 35 seconds or 40 seconds. You turn the
wait in the dark.
Yeah. I think that was very cool. So maybe I'll use it.
Yeah, you wouldn't have that problem with this.
Cool. Can you talk a little bit about the MCP 23008? So never used one of those. Is it?
Oh, I thought you had.
No.
Expanders.
No, I've never used one.
Oh, okay. If you're willing to buy enough of them, they'll give you. Well, no, there are 4 members of the MCP port expander family. 2 of them use I2C, and 2 of them use SPI. 2 of them are 8-bit, and 2 of them are 16-bit. If you focus on the 16-bit one, which I haven't used because I didn't really need to, it's very similar to the 8-bit one. If you use the 16-bit one, they have individually configurable addresses, so you can have 8 of them on an I2C bus. So that gives you 8 times 16 extra GPIO ports, which is probably enough for most of us. That's 512 extra GPIOs. Yeah. And you can fairly easily either write to a port or read from a port. You can control pull-ups. You can set an interrupt, which will toggle a line if a predefined condition occurs. They are really useful and pretty simple to use. The SPI version is quite unusual in that, like an I2C device, they have configurable addresses. So you can use a single SPI line, sorry, a single SPI port with the usual 3 wires and ground to control up to 4 devices. Because every time you want to send it a command, you actually need to send 2 bytes. One is the address and the other is what you want to do. And so that allows you, using SPI, which is in principle pretty fast, to give you a modest extra 4 times 16, 64 GPIO outputs. So they're pretty nice devices. One of the things which I haven't published yet, but I will, at some point over the next week or so, is code that allows you to use one of the 16-bit devices to control a numeric keypad with the bottom 8 bits and an old school LCD 4x20 display with the top bits. So now you've got a PICO and one other chip and the display and a keyboard. And there's all kinds of stuff you can do with that.
It'd be a good use case, wouldn't it? Any other questions? Or didn't want to take up all the time, but
yeah,
I've got a question. Is that you mentioned the different types of software, MicroPython, CircuitPython, and another. And my question is around libraries. As someone who's just dabbled in Arduinos, rely on some very clever people to have written some fabulous libraries. If I've got an application, something like NeoPixels, that I want to program or use a Pico for, is it better to look at what libraries I've got before I choose which CircuitPython or MicroPython or whatever, or are libraries compatible across different software products?
Okay, the quick answer is wait 2 or 3 weeks because things will be clearer. The longer answer is at the moment, if you are going to use the Pimoroni hardware, you've got to use the Pimoroni port of MicroPython.
Mm-hmm.
If you want to use the Adafruit CircuitPy libraries, of which there are a huge number, you'll have to use the CircuitPython version. And one of the things which I have on my to-do list, but it's been on my to-do list for a very long while, is I'm fairly sure that I can do a pretty simple bit of code that will allow you to use most of the Adafruit libraries with the standard MicroPython, at which point we'll all be in Clover. But the only reason I think it looks like it's pretty simple is because I haven't done it yet. So give me a couple of weeks and ask again.
That sounds like the right way to go, because
Yeah.
I don't want to back the wrong horse by learning something new and finding.
Well, and the great thing is that the difference between programming with CircuitPython and programming with MicroPython is pretty minimal. So I think nothing you learn will go to waste. It's really more a question of, oh golly, have I got to change the interpreter for this project again? It'd just be nice if you could have a single thing that you could run with everything. And if I can, I will make that happen.
Thank you very much.
Okay.
I've done some.
Oh, sorry.
I was going to say, I've done some porting of libraries myself for the Pimoroni stuff.
Yeah.
And I mean, the big thing that comes out of it is that the MicroPython port, basically, they tend to write the drivers in C, C++, and then put a MicroPython wrapper around them.
Yeah,
and that's why you end up
with the Adafruit stuff.
Adafruit tends to be all pure Python, so that most of the drivers, unless there's something right at the bottom, is the same across the Adafruit devices.
Yeah.
And the libraries get moved around more easily.
I'm fairly sure that I can replace board and bus I/O fairly easily, so that all the Adafruit stuff will run on the Pico with the standard MicroPython port. And if I can do that, that'd be great. You just use all the Adafruit libraries without change. But I'll believe it when I've done it.
Yeah. I mean, it's easy. Yeah, in a lot of ways, it's still easy to use CircuitPython because you don't have to worry about uploading code to the board because you just copy it across.
Yeah.
But you do live with that permanent device ejected dialog sitting in the top corner because it can't, as soon as you run anything, it resets the device. And we still haven't cracked that thing of stopping the flash drives going wrong like that. So, hey.
I have a question if I can.
Sure.
So I've been trying to use the PICO with C and C++, and at the moment, one of the issue I'm finding is the ability to have a clean workbench, in a way that I have one project with this make a file and all the library inside, and I can copy that project, make some modification on the library I want to import, and then write my code for it. The problem is that at the moment it seems like that the maker file is tied up to the example folder, and it seems like it's a bit complicated, because if I'm working on a project and say, right, I want to use the USB now, I have to go into the maker file, define the USB library, maybe copy them inside the right folder, and then hopefully compile. Is there anything? What's the best way at the moment to use C and C++ for like
I'm hoping
project?
someone other than me can answer that, because so far I have not done any C++ development. Okay. So I've done no C++ development. I'm afraid I don't know the answer. Hopefully, somebody in the group does.
Okay, thanks.
I've touched the C++ stuff a bit, and it is as awful as any other C++ development that I've done. So.
Yeah, what I didn't say is that when I first came across Smalltalk, C++ was the guru in the room, and I promised myself that I would not learn C++. I'm pretty well stuck to that for the last 20 years. Too scary for me.
Fair enough.
I don't know if anyone else can answer that question.
I guess I'm gonna have to improvise then.
Yes, so
When you find out the answer, let us know.
I will.
you're on your own, Pete.
Well, when I played with some microcontrollers like Blue Pill, well, the MicroPython, it's an interpreter and it's installed on the microcontroller and mimics a disk to put your files. But with the C and basically, well, my background is C and C++. Well, when I tried to program it, it was just to reprogram the microcontrollers. So basically, I used a programmer. I inserted it on the circuit, and I programmed from zero, like Arduino. On Arduino, when you are writing something there, it's just programmed on the chip. But if you are using that interpreters like MicroPython, normally the chip is managing the file to run it. So I don't know, maybe if you can integrate the C code or C++ code inside of a version of MicroPython and then install that interpreter on the chip.
Yeah, I will. C and C++ are not worrying me because it's my day job. I write code for microcontroller. And I was just wondering if there was already something like, I'm used to use a library called Embed on ARM microprocessor. This is an ARM.
The
ARM
high level is too easier work when you are programming, when you are creating the algorithm, I don't know, to control a device or something.
Yeah, well, it's more about abstraction of libraries, Embed it's more a matter of like time is money. That's it. And so I was wondering if it was already something like the great thing about Embed is that you can easily integrate new library and the code itself, and you can export this your code for different IDE. I guess my best bet is waiting until Arduino comes around and the support for the PICO come into the Arduino. So that will give me a reasonable integration. Not a great IDE, but at least a good compiler.
Okay.